So now we got an op amp here, the LM358, and I'm going to make a bunch of shorts out of this. That's why we're starting off so far away here, so that you should be able to see this whole circuit. But in any case, we have a relatively high input right here. I set a voltage to be about half the supply voltage. So if I turn the trim pot below half of the supply voltage, now the output is low. So a lower signal here than halfway, a low output, higher than half of the voltage at the signal, we have a high output right there. So the op amp here is a comparator, a non-inverting comparator. What we give in for the signal is what we give out, basically. That's what the non-inverting means right there. To set, in this case, half of the supply voltage, I have two equal value resistors to the inverting input that make a voltage divider for half of the supply voltage. So now we have the schematic diagram for this circuit, op amp that's wired as a non-inverting comparator. We got it kind of far away for those that are watching the shorts. Now we're going to kind of zoom in. This is the pin layout for the physical component. There's a couple op amps. We're only using the one on the left. Of course you have to power it. Output, inverting input, non-inverting input. Now when it comes to the circuit, you can see that a high output is red LED. A low output lights up the blue LED. But the main thing is, it's a non-inverting comparator. So we set a voltage at the inverting input right there, half of the supply voltage. So I'm just using 10K resistor, equal value resistors right there. We'll get half of the supply voltage. Trim pot, we can adjust the voltage. Now the output wants to be more like the non-inverting input. So above half the supply voltage, high output, and then below half of the supply voltage, you get a low output. So now we're going to make a short of powering this circuit, because a lot of people that watch my videos and shorts haven't really powered a lot of circuits. So the schematic diagram may not always show the integrated circuit being powered, but you always have to power it. And usually you power it with the same voltages as the loads. When you're looking at the actual component, positive supply is to pin 8 right there, negative supply is to pin 4. And then those supply pins right there provide power to the output, whether it's high or low. So that's how that works. And that's really about it. The rest of the power is going across the loads. We will look at the actual circuit. So right there, as I said before, pin 8 to the positive supply. You can see it moves up there and then comes back down over here. And pin 4 there is also to the negative supply to provide power to the integrated circuit. And of course it jumps back. So now we're going to devote this short to the inverting input. So I got it back, zoom back there for those watching shorts. We set a reference voltage to the inverting input when we want a non-inverting comparator. And so it's fixed to half of the supply voltage. There's other ways we could fix a resistor, but that's what we're using here. So two equal value 10K resistors. When you look at the physical component, of course you have to put it to the right pin. So that's minus there. It's above the plus. The plus and the minus can get swapped on the schematic, but you always got to wire it up based on the physical component. So that's what we got there. So you can see our two equal value resistors, 10K right there, going to the second pin down here, the non-inverting input. So no matter how it's drawn on the schematic, that's where you actually have to wire them together. You can see one to the positive supply and the other to the negative supply. So now we're going to take a look at the non-inverting input, or plus, when it comes to an op amp right there. And it's similar with comparators, but we're making a non-inverting comparator circuit here. So that's where our signal comes to the non-inverting input. That is what's changing. We get a higher voltage here, then we get a high output. We get a lower voltage here than what we set. Then we get a low output. So output follows. And so, yeah, we got the LEDs. We'll come back to that in the next video. But in any case, that's the third pin down if you're using the LM358. Other op amps have other pin layouts, and this particular op amp has two. We could use that one on the right for other stuff if we wanted to. So we will come here, and there you can see we got third pin down, you know, right below the inverting input, our jumper, to our trim pot, where we can get a variable voltage up to the full 5 volts or down to 0 volts. So now I like to end these short series with what the load is doing. So of course I made this for a short, so we'll start off far back. But yeah, we got an LM358 right there, wired as a non-inverting comparator. We got our two inputs there, and when the plus has a higher voltage than the minus, then the output goes high. So it goes through transistors. You don't get the full 5 volts, but it does its best to provide that positive voltage. Red LED lights up. When the output's low, because the plus is lower in voltage than the minus, then it connects to ground. That's why the blue LED lights up. Blue LEDs are brighter than red LEDs, so I got less current going. And of course, the output is the top pin of the op amp, whichever one you are using. You can see we got a second one there that we could also use. And there you can see we got our top pin there. Resistors, and then blue LED to the positive supply, red LED heading to the negative supply.